we are about to discuss the TCP IP model's transport layer. This layer basically is the backbone of reliable and efficient communication. This communication is done across the networks, and it also ensures that data is delivered correctly, efficiently, and in the right order. So what exactly is the transport layer? Let's look onto that. Guys, transport layer has the purpose of reliably transferring the data. Reliability is one of the key features that transport layer does. This particular thing would be considered as end-to-end communication. So let me just put the head at transport layer. Let me share the screen just a second. I hope my screen is visible. Yes, no? I just shared this screen. Okay. So we are about to discuss about the transport layer. Just a second. Guys, please don't annotate on the screen. Just this. Somnath, can you remove this scratch over the screen? Okay, let me do this. Yeah, fine. So we're talking about the transport layer here. If I talk about transport layer is basically the fourth layer of the TCP IP model. This is considered as the fourth layer of TCP IP model. And this particular layer basically acts as a bridge between the application layer and the lower network layer. I hope you all remember how basically the TCP IP model looks like. If I select this thing, so the top layer is the application layer, which is the combination of OSI's application, presentation, and session as well. Then beneath, we have the network layer and the link layer. So transport layer is working as a bridge between these two layers. The application layer, where the user interacts, and the network layer, where the handling of the data transmission over internet is done. Few key features of transport layers. That is what we are going to pen down here. Key features. This is a theoretical part, guys. So you just have to remember what all features do we have at transport layer and how does it works. The very first feature of transport layer is end-to-end communication. End-to-end communication ensures that your data has to be transferred between the devices reliably. And that is why the transport layer has two specific protocols available there. And the reliability feature is associated with the acknowledgement of it. We'll come to TCP and UDP and then we'll see which one is reliable and which one is the unreliable one. But you guys already know TCP is the one. Okay. So end-to-end communication basically depends upon the reliable transfer, the reliability. Other than end-to-end communication, the next feature of your transport layer is segmentation. What happens here is, okay, I need an answer from any of the participants available. Guys, what is the PDU of application layer? You guys can unmute and speak. Rather than typing in the chat box, you guys are free to speak up in the meeting, because like it won't be possible for me to like completely check every time the chat screen. Anyone? What was the PDU of application layer? Protocol data unit of application layer. Yesterday I had discussed about it. Anyone remember? Yes, no? I'll repeat it if you none of you remember that. Kushal? Niyaz?
Sir, it's Khushal. I think it's packet.
Uh, okay, packet is basically for the network layer. Thank you, Vishal. Uh, Packet is for network layer, the PDU. At the application layer, that means in OSI, if we talk, so application presentation session, all the three layers combinedly form application of TCP IP model, and this layer has the PDU as data, the user data that is generated. Okay, and once this data is sent down towards the transport layer, it is broken down into smaller pieces with the process of segmentation, and that PDU which is generated here, that is called as segment. So with the help of segmentation, the smaller chunks of the traffic which are generated, that is called as segment. You have data, you have transmitted your data over to the transport layer. Transport layer will perform segmentation over to your data so that it can be transmitted easily, and like this, smaller chunks of your traffic would be created. Now what happens is, these all different chunks needs to be identified, and in order to identify them, I'll have to associate the sequence numbers to them. Generally, sequence numbers are in hexadecimal format, but just for our understanding, presently I'm using decimal number systems, so I've placed them as 1, 2, 3, 4, or else it could be in a hash code in reality for the systems. So what happened? These sequence numbers are associated to the segments, and this is also one key feature of transport layer, which is called as sequencing. Sequencing is a process through which the transmission of the segments has to be identified with the numbers, and that is what is called as the sequencing, which assigns the sequence numbers to the segments. Now what happens? Let's assume shifting of our house luggage. Let's say I stay in this particular building, and I am about to relocate to a newer location. In order to relocate to a newer location, I'll definitely call packers and movers who will be responsible for shifting up my luggage from one location to another location. So yesterday also I repeated the same thing, that I have two truck drivers available. One is Mr. TCP, very responsible one. Other one is Mr. UDP, who is a bit crazy one. He is not that much responsible because he like to do everything very quickly and carelessly. Okay, so what we'll do, what we will be doing, we will be basically loading up our luggage onto these particular trucks. Similarly, your traffic, your data would be broken down into smaller pieces. That means, let's say, if you want to relate it with the house shifting, so every particular segment here is basically the luggage of a room. Let's say this is bedroom, this is kitchen, this is living area, this is hall. So all the different luggages would be packed up in different segments. Okay, do we have a method that, okay, fine, at very first place I'll pack kitchen's luggage, then I'll go for the living area, then I'll go for the hall? Is there any proper sequencing defined for the packers and movers? No, this packing is always done in a random manner. Similarly, whenever the transmission of traffic is done, that means the transmission of segments is done, these segments are also transmitted in a random manner. It might be a case that when the sender is sending these particular segments, the sequence could be 3, 4, 2, 1, a random sequence. So there is a need at the receiver's end to rearrange these particular segments into a proper sequence. And that is another feature of transport layer, which is called as reassembling of traffic. Sometimes what happens, your traffic might get lost, your data segments might get lost in between. So retransmission is also, you can say, retransmission or error detection. Recovery of traffic or error detection is also one key feature of transport layer. Messaging flow, the flow of the traffic. Sometimes what happens, let's say your receiver is getting overwhelmed with the traffic that you're providing. Then transport layer has one more key responsibility, that is called as the flow control. So flow control basically manages the entire traffic flow between the sender and the user, so that none of them are basically getting overwhelmed, or traffic bottleneck should not be created there. That is also one of the key feature of transport layer. Transport layer also performs multiplexing and demultiplexing. rarely discussed, but we should associate this thing also in our studies. Multiplexing and demultiplexing is also one of the key feature that transport layer performs. So every individual application will be utilizing a specific port number so that they can ensure that your traffic has been sent to the correct application. So these are the key features, guys, of transport layer. Now, we'll move on to the second point of the explanation, where we are going to see what exactly are the two key protocols which are used at this particular layer, which is TCP and UDP. So let's start with TCP first of all. TCP stands for Transmission Control Protocol. This particular truck driver is very responsible, and that's why it is identified as a reliable protocol. TCP prefers to maintain a connection or establish a connection before transmitting the traffic. This particular connection is established as a virtual connection before your original data transfer will begin. And that is why it is also considered as a connection-oriented protocol. With the help of this particular feature of reliability and being a connection-oriented protocol, TCP always ensures the reliability, the ordered delivery, as well as the error-checked delivery of your data. The key feature of TCP, let's look on to that too. The very first feature is called as the three-way handshake. Which establishes the connection. It is used for connection establishment. Then we do have the second feature, the four-way handshake. Which is used for the termination of the connection. So we'll see basically how three-way handshake and four-way handshake work all together and go hand in hand. Let's look on to that. I'm assuming that I am PC1. And PC1 is trying to communicate to PC2. So in this scenario, PC1 and PC2 wants to transfer data between them. In order to transmit the traffic, and being TCP the core protocol which is being operated here, the very first preference of TCP would be to establish a connection. In the segment level, before your communication starts, TCP always establishes this reliable communication with the help of three-way handshake, where the very first information that would be sent from the sender towards the receiver. Let's assume PC1 initiated the communication. At the very first hand, PC1 or the sender will initiate a SYN flag, which is one of the field segments available in form of flags in the segments. SYN flag basically means synchronization flag. Synchronization flag means that PC1 is saying yes, I want to build a connection with you. It is requesting that I want to make a connection with you. And being such a polite person, he is basically just asking that I want to connect. Can I connect? In reply, PC2 or the receiver do have to reply with an acknowledgement so that the connection can be established. So PC2 will revert back with an acknowledgement which would be the reply for this particular synchronization flag. Along with that, only one-way connection establishment won't work for TCP. That means PC2 also needs to be connected back towards PC1. So PC2 on his behalf will again share another synchronization flag which represents that PC2 also wants to connect back to PC1. Acknowledgement means, okay, I want to connect, and synchronization means I too want to connect. And as again synchronization flag has been sent towards PC1, PC1 will again respond back with an acknowledgement. And this is the acknowledgement which basically creates the reliability between the TCP related protocol operations. So another acknowledgement would be reverted back. And once both the devices have exchanged the acknowledgement for the communication, then only the communication stream gets established. Here ACK means acknowledgement flag. As we can see, this is a three-step process. One, synchronization sent. Second, acknowledgement with the reply of synchronization, and another synchronization has been sent. Let me just change this color so that it could be easy for anyone to just look at the diagram and understand. Just a second. And then the third step, where the acknowledgement of the second synchronization flag has been reverted back. Being this a three-step process, this particular process is called as the three-way handshake that helps to perform or establish the connection between the devices. After three-way handshake has been done, the reliable transfer between the devices start. TCP will ensure that the data is being received accurately and in correct order. If packets are being lost, then they will be retransmitted. So data sharing has started here. Now what happens is, if we are utilizing a connection established stream, definitely that stream needs to be free for other users to utilize. Let's say if I have PC3 also available in the environment, there would be a case that PC3 also wants to communicate to PC2. So I'll have to make the stream vacated once it is free. So what happens is, once the data sharing is done, connection needs to be terminated also. So let's see how the connection will be terminated. I'm assuming that either of these two devices, here this is PC1 and here this was PC2. So either of these two devices, one of the device has stopped communicating or was finished earlier. So I'll assume that PC2 finished earlier his data transmission. Once any device is done with the data transmission, it is the responsibility of the device to immediately initiate the finish flag. Fin means the finish flag. That means I want to terminate the connection. As PC1 has received the finish flag, it is the responsibility of PC1 to give the reliable support. That's why it will revert back with an acknowledgement. But this time, only acknowledgement will be sent. Why? Because this could be a scenario where PC1 is still transmitting the traffic towards PC2. So let's say some more time passed out, and then PC1 is also done transmitting the traffic. So what PC1 will do? PC1 will again send the finished flag because it is done transmitted. So PC1 will again share back the finished flag that, okay, fine, I also want to terminate the connection. Finished flag has been sent. Responsibility is to revert back with an acknowledgement. PC2 will revert back with an acknowledgement. And you can see this is that 4-step process which will ultimately result to terminate the connection. And that is why this is called as the 4-way handshake. Connection terminated. And now the stream is free for any other particular application to get connected or any other device to connect and transmit the communication. So guys, here we have seen 3-way handshake and this particular element of 4 stages, which is the 4-way handshake. So 3-way handshake is utilized by TCP to establish the connection, and 4-way handshake is utilized by TCP to terminate the connection. Other than these 3 flags that I have explained here, do remember there are some more flags available in the TCP protocol. TCP protocol might utilize few more flags. What are the name of those flags? One is called as the reset flag. Let's suppose you have established a connection between 2 devices, but these 2 devices were not the exact legitimate device where you want to send the traffic. Let's suppose I'm a sender and I'm sending my traffic to PC2, but I was meant to send the traffic to PC3, but mistakenly I established a connection with PC2. So in such cases, your connection can be resetted back. And for that, the device, the sender, would send out the reset flag to reset back the connection. Other than reset flag, we have another flag which is called as the push flag. If there is any urgent traffic that you want to push into the stream of the communication, push flag will do the cause. Then we have the URG, the urgent flag. What urgent flag does? Let's suppose there is a very important traffic that has to be sent at the highest priority rather than the entire traffic, just like our ambulance does in their traffic lane. Let's say if I'm driving on a 6-lane road and there is an ambulance, humbly every particular driver would give a sideway so that the ambulance can pass on through the traffic. The same thing will happen with the urgent flag associated to any particular segment. Any very high priority traffic that you want to send out at the very first hand, for that kind of traffic, urgent flag would be associated to such segments. So these are the 6 flags that everyone should remember the name of, and why which flag is associated onto the segments. Sometimes push and urgent flag could be a bit confusing, but always remember push will be for ongoing stream and to enter another traffic that needs to be sent out, whereas urgent is to stop the stream and first of all give the highest priority of the transmission to the important traffic. That is the difference between push and urgent flag. So if I talk about TCP, I have explained this, its core features also. Guys, where would be TCP be used? Talking about where is TCP used, the very first case could be the web browsing. Where the protocols like HTTP, HTTPS are used. Any other example? I want few examples from you guys. Just give me at least 2 examples of TCP. What are the applications where TCP is used, guys? Okay, one Anup said email. Yes, Anup, you're correct. Email is one of the examples for TCP. And can you help me with the protocols? What are the protocols which are utilized for emailing?
File transfer.
FTP, okay, fine. File transfer. Oh, I said the email, I got SMTP. I need one more name.
Remote
Remote access. Yes, that is also one of the feature. But guys, before telling me the where it is used, I want the name for the protocols of emailing. What are the email protocols available? SMTP is one of it. We have discussed. Is there any other protocol or only SMTP is used for emailing?
Three.
I missed your voice. What are you saying?
POP3.
POP3. Yes, that's correct. Have you guys heard of IMAP? IMAP is also one of it, right? Okay. Now coming to file transfers. FTP. What else other than FTP? Anything a protocol similar to it? Okay, Anoop has a very fast fingers. Yes, Anoop. TFTP is also one of it. Now comes to remote access. That one of our friend answered. Okay, whose answer was remote access? Who answered that?
Me, Ravi.
Okay, Ravi. Ravi, can you help me with some remote access protocols? Arey Baba, very easy. Telnet. Telnet is one of the protocol, right, that we use for remote access. Although it is not secure, that's why it is not implemented, or it is not given a higher priority in the industrial environment. What is the secured one? Yes, SSH. So all these cases of file sharing, data transfers, accessing any particular server informations, right? Remote accesses over to any particular destination or a different device. In all such cases, reliability is a key factor. That means acknowledgement will be available there. So that is the reason why TCP is used in such scenarios. I hope this much is clear for everyone. What we have gone through is what was the transport layer. It is the fourth layer of TCP IP model, where the PDU is segment. The key feature of transport layer are end-to-end communications, segmentation, sequencing, reassembling, recovery of traffic, flow control, multiplexing, deplexing, for which the port numbers are used. Then I jumped on to one of the key drivers who are going to take away our traffic from one location to another, Mr. TCP. What was TCP? TCP is basically a reliable protocol, and often it is referred as the connection-oriented protocol. Why is it called as connection-oriented? Again, a question. I just want a repetitive answer. Why the TCP is called as a connection-oriented protocol? I need an answer, guys.
काम करना मेरा फोन चालू रखना चालू रखना दिव्यांग व्यक्ति નું ટ્રકની ટક્કરથી કમકમાતી ભરી મોત દિવ્યાંગને કચડ્યા બાદ ટ્રક ચાલક ત્યાંથી નાસી છૂટ્યો હિટ-એન્ડ-રનની આ ઘટનાના સીસીટીવી વાયરલ થયા છે.
Okay. That was the answer which I couldn't understand. Okay, so guys, see, connection-oriented protocol basically means that TCP always establishes a connection. And whenever you are referring for the connection-oriented, always remember we are basically mentioning the handshake process, the three-way handshake and the four-way handshake for establishment of the connection and termination of the connection. Okay. Now, after TCP, another protocol that we have is Mr. UDP. UDP stands for User Datagram Protocol. Unlike TCP, UDP is connectionless protocol. UDP will never establish any connection before sending the data, and it will never ever guarantee you the guaranteed delivery of the traffic. And that is why the transmissions here are quite faster but less reliable. Talking about the key features of UDP. The very first feature, although it is not any feature, but yeah, it would be identified as one of the characteristics of UDP, which is no connection establishment. Here, data would be immediately sent out without even any handshake process, and that is how latency is reduced with the help of UDP. Okay, who will tell me what exactly latency means? Guys, what is latency? Ravi, would you like to answer? Ravi, Somnath? Anup, would you like to give a hand? What does latency means? Delay, exactly. Latency is basically the delay of the traffic. So, as we have discussed already, right, that UDP is used for faster transmission of traffic. So, without establishing a connection, that means that the three-way handshake process will not undergo, and that is how the time will be saved out. That's why TCP becomes slower, because it performs three-way handshake, whereas UDP, it never performs three-way handshake, and that is why it becomes faster. Here, error checking is also not done. That's why it becomes more faster. Overhead is also very less here. The cases where UDP will be used, we can consider online gaming. Online gaming is one of the platforms where UDP protocols are introduced for fast gaming experiences. Video streaming, just like this live meeting of Zoom. It could be your Netflix. It could be YouTube or Zoom calls. Then the voice over IP phones, the VoIP calls. This also utilizes UDP. If you are using the DNS queries, the DNS queries is also one of the example for UDP protocol. So now what happens? We are done with TCP and UDP's theoretical explanation. Now we'll simply understand what exactly these applications are identified within the transport layer. So once your data comes down in form of segments at transport layer, you'll be able to identify two different segments: TCP segment and UDP segment. Applications resembling TCP or applications resembling UDP will contain a port number within this particular segment. Port number specifically identifies which particular application has to be gone through what door. So port numbers are kind of a door that let pass through the applications from transport layer towards the network layer. Talking about port number, guys, this port number is a 16-bit entity. Bits means two values, 0 and 1. So a possible combination of these two values, that means a 16 possible combination of these two values, is what is meant by 16 bits. So 2 raised to power 16 will give you a value of 65536, which starts from 0 and ends up at 65535. These port numbers are categorized into three different variants. The very first category of the port numbers is called as the well-known ports. The popular port numbers, the popular applications that we always refer, even I was using in my example the applications which were the protocol associated to the well-known port range: HTTP, FTP, SMTP, DNS. All these particular ports or applications come under the well-known port range. This particular well-known port range starts from 0 and ends up at 1023. The second range is called as the registered ports. Registered ports range starts from 1024 and this ends up at 49151. This is used specifically for some specific applications for which a reservation has been requested, and it will be reserved with the help of INA. After registered port, there is the another category which is called as the dynamic port range or ephemeral ports. This particular port range starts from 49152 and ends up at 65535. These particular ranges of the port numbers are utilized for temporary use cases. For cases where, let's say, your traffic has been overloaded, so you can utilize a mirrored port from this particular sequence. You can mirror your port traffic to that particular port again. So for temporary use cases, dynamic port ranges can be utilized. Every application which is running on a device will be having a unique port number. So whenever your data will be sent, the source port and destination port, these two informations would be associated within the segment. And the receiver who is using this information will be directed that particular data for the correct application. If you want to understand a real working of a transport layer, how exactly transport layer works in real life, so let's understand a real life example for it. Guys, I won't be using any simulator or any simulation tool as of now because we're just going for the theoretical part. But once we'll start doing the labs, the same thing will be explained in form of the real practical. We'll check by typing up the web addresses and we'll capture the traffic. We'll see how the traffic is flowing. But presently being the theoretical part, I'm just giving you the notes material, like writing out the explanations for you guys. So let's say I'm setting up on a PC. I opened up my web browser and I typed www.google.com over to my PC. So how will the transport layer play a role here? The very first step that will happen here would be that my browser, it is the responsibility of my browser, or you can say in this case the client for a server. My browser will send out a request using TCP. This request would be sent out to whom? Towards the server. Any particular web server available in the environment of the Google, right? So what will happen here is, at the segment level, the source port number and destination port number have to be associated. So let's say the source port number was a randomly selected port number, which is 52345. This is the source port number. And the destination will completely depend whether our traffic is HTTP or HTTPS. So I'm assuming that my traffic was contained via HTTPS. So destination port number here would be 443. So this way the layer 4 traffic will be transmitted towards the server. Now the second case, or the second responsibility, is of the server. Here what will happen? The server will respond back with the acknowledgement as the TCP connection has established. Here, synchronization flag must also have been sent, okay, because initial communication is being happening. The revert of this particular thing would be the revert of the synchronization and acknowledgement flag. Once this revert has achieved, data transfer will begin and every packet will be received correctly. Once the web page has been loaded, the connection will be closed, and to terminate the connection, the four-way handshake will happen between the server and the client. So that is how, while accessing a web browser or any particular web server with the help of your web browser, the TCP comes into the action. So if I want to summarize this particular explanation of the transport layer, guys, transport layer basically functions for the reliable and fast communications via TCP or UDP. It will always ensure the correct delivery and will manage the network congestions too. They also utilize the port numbers, and with the help of port numbers, they will direct the data to the correct applications. Here, the seamless functioning of the internet and the network applications will be happening. To conclude this part of transport layer as of now, transport layer, guys, is a very essential part of TCP/IP model. It will always ensure that your traffic or your data reaches to its destination efficiently and reliably. Whether you are browsing the web browser, you are streaming videos, or you are playing online games, transport layer is always working behind the scenes to manage the communication. I hope you guys are able to understand what exactly is the transport layer, the entire story of transport layer. Was that clear for you guys? Yes, no? Only Anup is replying back. I hope everyone else is available here, guys. Niaz is there, Anup is there. What about others? Okay, I expect everyone is listening to me, okay? Because in the tests, I will be asking all these things, whatever I'm uttering out for you guys, okay? Okay, Ravi. Thank you, Kushal. Kushal, I spelled your name right, correct? It's Kushal, correct?
Yes, Khushal. Yes, sir.
Okay, thank you so much. Okay, guys. So after transport layer, my traffic would be pushed down. That means over to the TCP/IP model. Application layer was there. It sent out its data towards the transport layer. Transport layer converted this data by the process of segmentation into smaller segments. Now these segments are loaded up onto TCP or UDP trucks, and they have to be transmitted to a destination. So the locations have to be identified, for which the network layer will come into action now. So the segments are identified or stamped out with the internet protocol informations or IP informations, and they are called as the packets. You can identify two different packets. One would be your IP version 4, the IPv4 packet, or other one would be your IP version 6, the IPv6 packet. This comes to the study of the network layer. The network layer. Yes, network layer is the third layer of your TCP/IP model. I'm talking about the 5-layered structure, okay, not the link layer directly. Here, data link and physical are separate as of now. So it will be considered as the third layer of TCP/IP model. The process or the working of network layer is to provide a logical addressing. For which it utilizes a protocol which is called as the internet protocol. Your internet protocol is categorized, or it has two specific versions: IP version 4 and IP version 6. Version 4 is often written or mentioned in 32 bits, 32 binary bits, whereas IP version 6 is represented in 128 bits. "32 bits means 2 raised to the power 32 possible combinations of the binary bits, which ultimately goes for 4, 2, 9, 4, 9, 6, 7, 2, 96 possible IP values. So guys, from now onwards, I'm going to put a hold on IPv6. We will resume IPv6 once we are done with the entire study of IPv4. That means every specific protocol you are going to study first of all on basis of v4. Then within a day or two, I'll quickly tell you the switch between v4 and v6, how the migration has been done, how the changes of the configurations and the understanding of the protocols will be done. So for that, we will again unhold the IPv6 during the last 2 weeks of our training sessions. That is when we will be understanding IPv6 back again. And that way, it would be very easy for you to cover everything of the syllabus on basis of v4 as well as v6. So for now, we will only focus on v4 as of now. So these 32-bit IPv4 address, it is represented in decimal notation. The 32 bits of this IPv4 address is bifurcated into 4 octets. It has 4 octets, where 1 octet makes up of 8 binary bits. They are divided by a period in between, or you can say a dot. So if I were to explain, or if I were to represent an IPv4 address in form of X, an IPv4 address might look like this: X dot X dot X dot X, where a single X is basically an octet. And this specific octet combines of 8 binary bits. If I want to represent that octet in 8 binary bits, my octet would somewhat look like this: 1, 2, 3, 4, 5, 6, 7, 8. So in terms of binary representation, if you want to see how an octet looks like while going into the binary form, this would be your entire IPv4 address in 32 binary bits. This is how it looks like, having the dots between the 8 binary bits of the addresses. Now, if I talk about this particular specific octet again, let's only focus on a single octet now. Combining of 8 binary bits. Guys, how many of you remember the 6th, 7th, or 8th standards mathematics of your school? Yes, no, anyone? Addition, subtraction, larger number, smaller numbers, largest integer, smallest integer. So in those times of our schools, we were used, means our teacher, mathematics teacher used to ask us one question. And that is what I'm going to repeat for you guys too. What is the 3-digit smallest integer? Tell me the 3 digits smallest integer number. Come on, I need the answer. Guys, I'll need answers from you guys also before, means in order to continue the sessions. But without communication, it would be a very troublesome problem, I think, for me to communicate and deliver the session. Hello, I hope everyone is here. Guys? Zero. Okay. And I'll represent that zero like this. 0, 0, 0. Can it be a 3-digit smallest integer? In our mathematics, the smallest 3-digit integer would be 100. And what if I ask the 3-digit largest integer? Definitely the answer would be 999. The reason is, in our mathematics, we humans basically understand or learn the entire mathematics on the basis of the decimal number systems. And the decimal number systems start from 0 and end up at 9. But what if I convert this calculation to binaries? What would be the 3-digit smallest binary number? Then definitely it would be 000. Because in computers, 0 itself is a value. Similarly, the 3-digit largest binary number would be 111, because a binary number only has 0 and 1. In the same manner, now I'm going to identify what exactly an octet gives me out as a value, for which binary to decimal conversion is something that we need to learn. How many of you are good with binary to decimal conversion? I need to answer from everyone. That is only how I will be proceeding ahead. Either use the voice or chat box, but I need an answer from every attendee here. Guys, who all know the binary to decimal conversion properly? Okay, so see. Here, we first of all will identify how this octet is useful for us. And for that, we need to convert the values of the octet into decimals. Before that conversion, first of all, let's see what exactly this octet means. Ultimately, over to these 8 places, 8 binary bits will be placed. Either all the bits could be 0, which will give me the very least value of the octet, or all the bits could be 1, which will give me the maximum value of this octet. If you guys remember the traditional method of calculating the binary to decimal conversions, that particular traditional method was to take out a value, let's say 168. And if I now want to convert it into binaries, what I'll do is, binary has a base value of 2. So I'll use 2 and start dividing this value. So 2 8s are 16, 2 4s are 8. Remainder 0. Again by 2. 2 4s are 8, 2 2s are 4, 0. Again by 2. 2 2s are 4, 2 1s are 2. Carry 0. If I'll again divide it by 2, I simply know that 2 10s are 20. Remainder 1. Again by 2, 2 5s are 10. Remainder 0. Again I'll divide by 2. 2 2s are 4. Remainder 1. And last division again would be done by 2. And 2 1s are 2. Remainder 0. So this decimal number 168 having a base of 10 can be rewritten as in binaries with a base of 2. And for that conversion, I'll write it from down to up, which would be 1 0 1 0 1 0 0 0. But this method of converting the particular decimal number into binaries takes a time. And if we'll keep on doing this like this, it will take a lot of time for us to understand the subnetting questions and subnetting problems that would comprise enough of your certification exam weightage of the questions, as well as your industrial implementation, where you need to bifurcate the network into smaller segments or smaller subnets. So what we are going to do is, rather than performing this traditional method, we'll jump on for an advanced method, which will be represented with the help of the binary place values. What exactly are the binary place values? Just like in our decimal number systems, we have ones, tens, thousands, 10,000s, lakhs, 1 lakhs, 10 lakhs. Like that, we have the place values for the decimal number systems. Similarly, for binary number systems, we have the binary place values, which means if I have an octet having 8 binary bits, if I talk specifically about this particular binary bit, here only 2 possible values can come, either 0 or 1. That means only one binary value will be placed here. That is why we rewrite this with a place value of 2 raised to the power 0. After 2, any one value can come. And we know mathematically, any particular number having a power 0 will give you a value of 1 only. If we take these two in combination, possibly 2 values can be placed here. So that will become 2 raised to the power 1, which will give you a value of 2. Similarly, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4, 2 raised to the power 5, 2 raised to the power 6, and 2 raised to the power 7, which will ultimately give you the values being doubled every time: 4, 8, 16, 32, 64, and 128. These would be considered as the binary place values for your binary number systems in the octets. So with the help of these particular numbers, I'm going to tell you or I'm going to educate you about how quickly you can convert the decimal numbers into binaries. I'll do 2 questions. After that, I'll give you the questions. You guys have to answer that particular thing in the chat. If you are not able to understand, then please ask whether I have to explain back again or not. If everything is understandable, then I'll expect you guys to answer the questions. So let's start. Similar question, which was the above. 168. First of all, let's get to a fresh page, and I'll just copy this thing. In order to follow me, what you have to do is just simply write this particular 8 values at the top of your page. Now let's assume I have to convert 168 into binaries. So how can I do that is, I'll start placing 0 or 1 below these values in order to create this value. If I am including any value for the addition, I'll place it as 1. If I'm excluding any value from the addition, I'll simply place it as 0. So in order to build or to create 168, can I take 128 or not? Yes, I can take it because it is smaller than 168. So I'll place it as 1. Now, in order to do the calculation, simply subtract 128 out of 168. You'll get 40. In order to create 40, can 64 be taken? No, it cannot, because it is higher than 40. So I'll place it as 0. Now, 32 can be taken because it is smaller than 40. So I'll place it as 1. And again subtract 32 out of it, which will give me 8. It simply is visible that 8 is here. So definitely 16 cannot be taken. I'll take 8 here, and rest all the values would be 0. And this is the conversion of 168, which is 10101000. Let's do another question here. The next value would be 224. So converting 2 to 4 into binaries, I'll place 128 as 1 because I'll have to include it. Subtracting 128 out of 224, I'll get 6. This will be 21, 12, 8, and 1, 96. 64 can be taken, place it as 1, subtract 64 out of it. This will be 2, this will be 3. 32 is directly here, so I'll place it as 1, remainder will be 0. That means this is the binary conversion of 224. This way, you guys can easily convert any specific value into binaries. So I'll be closing the today's session part here. Nice, Somnath. I read the chat right now. Okay, thank you. So guys, for today, we'll be closing up the part here because our today's target was transport layer, which is already done. From tomorrow onwards, we'll be jumping on to the IP calculations, understanding the network layer packets, how an IPv4 packet looks like, how the IPv6 might look like in the above coming sessions. Tomorrow, calculations would be like binary conversions, understanding the subnets, what are the IP values we do have, how long this exact IPv4 address extends up to. All these things would be discussed in the tomorrow's session. Is there any question for today? Please ask, guys. Okay. No from Anup. Somnath, any question? Kushal, any question? Okay.
No, sir.
Okay. Riaz?
No.
Okay. Ravi, all good?
Yes.
Okay, amazing. So I hope no one has any question, guys. Shall we wrap up for today?
Yes, sir.
Sure. Okay, guys. So this was a session for today where we have discussed about the transport layer. We'll again start from the network layer tomorrow again, and we'll move ahead and we'll see how the conversions are done. For today, what you have to do is take any value in decimals and try to convert it into binaries with the help of this, or take any binary value combining of 8 binary bits and try to reconvert it back into decimals by adding up the values where you have placed 1 as. This will be the only thing that I wanted you guys to take forward or carry away from today's session, the conversion method. Tomorrow we'll see how this conversion method will help you to quickly solve any subnetting question within 2 or 3 seconds, whether it be a large verbal question, scenario-based subnetting question, requirement-based subnetting question, anything. I'll help you guys to learn how quickly you can solve those questions. That would be the case for tomorrow. So thank you so much, guys, for being with me here. And yes, one more request, please try to unmute and speak up with me. Try to interact with me, because or else it will become very boring for me to without interaction to explain the things out. Okay, so I expect you guys understand that.
Can you give us the outline?
Yes. Can I give you the what?
The outline, like what we're gonna do next.
Okay. Yeah, I explained the same thing here. Can you help me with your name's pronunciation, please? What's your name?
You can call me Teddy. Just
Teddy.
Yeah, Teddy's
Ted.
good.
Okay, hi Ted. Very good evening. So Ted, tomorrow we are going to learn about network layer. We'll understand the IPv4 addresses, how many classes we do have in v4, how those classes have been derived with the help of the prioritization of the bits, which is a concept that INA implemented for classes verification or classes identification. After that, we'll see the reserved addresses too. What addresses are reserved, what classes of the addresses are reserved, for what purpose are they reserved, and how reserved addresses are not utilized for the allocation of the host devices. After that, we'll go for the types of IP addresses, because we have 2 versions, v4, v6. We have 5 classes, A, B, C, D, and E, and we do have 2 types, private and public. So how these particular things of the IP are one of the elements or entities in the IP addressing, that we'll see. And then we'll quickly move on to the subnetting questions. What subnet is, what is network IP and broadcast IP, how that can be identified with the help of subnet mask. That is something that we are going to cover up in tomorrow's session.
All right, thank you.
You're welcome, Ted. Okay, guys, have a nice evening. We'll catch up tomorrow at the same time. See, generally the batches are from Monday to Friday, right? But we will be taking up a batch tomorrow. Will that be possible for everyone to join?
Yes.
Okay.
Yes, for me.
Amazing. Okay, guys. So thank you so much. We'll catch up tomorrow. Have a nice evening, guys. Bye-bye.
Yeah. Thank you.
Thank you.
You're welcome.